This is the second part of this SQL tutorial. So in this video we will learn some more functions in SQL. So here you can see we have the product number, and let me zoom it, and here you can see there is AR dash, and we need to find the index of this dash. So for this we have to use char index. The new column will be product underscore char index is equal to char index, and the first parameter is the expression that we need to search for, dash, and the second is the column, that is product number, and we don't need to give the third parameter. Third parameter is the option where we have to specify the start position. If we don't specify the third parameter, it will automatically start from 0. So close. So let me execute. So here you can see the product char index is 3 because the dash is in the third location. So that's why 1, 2 and 3. And let me show you one more thing. Okay, for example, if I write here 0, start from the 0th position, execute, and see we are getting the third position. It doesn't matter, we can also write here 2, and we will again get the same, because the after second position, if we again count, then the index for the dash will be 3. So it will count from the beginning to the end where it find dash. Okay, and let me show you one more example here. For example, here we need to find out the dash because here you can see we have 2 dashes here, bk dash and then r50b dash, and we want to find the location or the index for the second dash. How we can achieve this? For this we need to start the position from the 4th, 5th, 5th or 6th. So after dash the position is 4, and now execute. So here you can see after 4 there is no dash, that's why we are getting here 0. And if we see here, so here you can see the position is 8th. So it is very useful function for the, we use this function extensively for the data validation. The second function is null. So for example, here you can see we have a color, and we can write here if the color is null, then we need to go for the product line. So let me find some suitable. Okay, for example, there is product color, and we can write if the product color is null, then use the product number. So how we have to do this? New color, and is null. The first parameter is what we need, color. If color is null, then we have to use the product number. This one. Execute. So here you can see if the product color is null, then it is replaced with the product number. We need to enhance it a little bit more. For example, if we say if the color is null, then use the product line and execute. So here you can see the new color is null because the color is also null and the product line is also null. That's why we are getting null value. And we need a nested is null. If the color is null and the product line is null, then use the product number. So what we have to do here, we use one more is null, nested null, and this is the first expression, and then the second one will be the product number. Close it, and here you can see now we are getting the product color is getting the product number because the color is first it checks the color is null, then take the product line. If the product line is null, then take the product number. So we have to achieve this result by using nested null. You can uh, put some more is null according to your situation. So let me show you one more function here, that is Coalesce. So it will behave the same. It will always return you the first non-null value. So we need to write new color underscore and here will be Coalesce. So the first value what we are looking for, it is color. If color is null, then go for the product line. If product line is null, then go for the product number. That's it. And now we need to execute. So here you can see we are getting the same result. So this Coalesce is very handy function. We don't need to use multiple times is null function. After this, we need to talk about some group functions. So let me copy and paste. And we need to get rid of this. Execute. So here you can see we are having colors and list price, and we need to count the list price by color. So what we have to do, we need to remove these columns and we are only interested in color and list price. So here we have to use the first column color and the second column will be the total price is equal to sum. This is a group function and it takes one parameter, one int, float, anything, so that the sum can work. And if I execute, we'll get one error that the production dot product color is invalid in the select list because it is not contained in either an aggregate function or group by clause. So we need to use here group by color. And now if I execute, so here you can see we are getting the total amount by product color. If I don't use color and we don't need to use product by as well, then we will get the total amount. Let me select and execute. So this is the total price across all the colors. So let me execute it again. And in the same way, we can use here like product count is equal to, so we need to use one function count, and here we need to give the unique number of products, that is the product number or the product name. Product number, and one more we can write here, min price is equal to min and list price. Max price, list price. So let me execute. So here you can see the total price for the black color is this one, and the number of products available for the black color are 93. The min price is 0.00 and the max price is 3374.99. In the same way, we can see the statistics for the max price, min price, product count, total price per product color. So in this way, you have seen that how we can utilize these functions to get valuable insights. Now we are interested in, for example, if we say we are only interested in those colors where the product count is greater than 50. So what we have to do, we have to use here uh, group by plus having clause, this one. So let me copy. We have to use here, for example, okay, we can leave this min max as it is, there is no issue. So group by color, and we have to use here having, so we need to use the same aggregate function, control C, is greater than, for example, 40, and let me execute. So here you can see we are able to see only those colors where the product count is greater than 40. So we have 43, 93 and 248. So if we use here, for example, where clause, just like we did in the having here, and where you will get a syntax error. Okay, so if we copy and we use after the from clause, and there is no syntax error, and now if I execute, see, we are getting an error that aggregate may not appear in the where clause. So whenever we have to use group by, and for the implementation of the where clause, we have to use group having clause. Having will only work with the aggregate function condition. Let's talk about subqueries in SQL. Subqueries. So we need to achieve the same result like total price per color using subquery without group by. Control C, Control V. So Here we have to execute this query, select color from production.product, and here we are able to see the 504 rows because there are duplicate colors, and we need to use here distinct and execute. Either this way, either we can use group by color. So we can achieve the same result as we have decided not to use group by. So we will use here distinct. Okay, and the alias for this table will be P1, and now we have to use another column, that is total price is equal to. So we have to use the subquery, select sum list price from production dot product P2. The alias for this table is P2. Alias are used for the simplification because otherwise we need to write here the complete name production.product in the where clause. So where p1 dot color, either we can use p1 dot color or we have to use production dot product dot color like this. So I mean we don't need to use the complete name here, the schema name, table name, and then column name. So we will use only the p1 dot color is equal to p2 dot color, this one, right? So that's it. So we need to find the sum of list price where product color is equal to product color from the first table to the inner table. So let me execute. So here you can see we are able to see the total price per color. So this is how we can achieve the same result without using group by and having. And if we implement the same like a count, so we can write here the same. We need to copy this one, Control C, and we are only interested in where the price is greater than like 200. So we are getting 10 rows before, and after execution of this query we will get 7 rows. So this is how you can work with the subqueries. So there is one more flavor. We can write one more query here. For example, if I execute, we need to get rid of the index and new color because we are not interested. And so here you can see we are getting 504 rows. And let me write one more query here from production where, and we can use the alias name here p1. So either you can use p1 or not, it doesn't matter. So we can say where color in So here we have to write another subquery, select color from production dot product where color in red and black. This one. So if I execute this query, see, if you look at the color column, we are only able to see the black and red colors because this is the subquery that only return those colors. Let me write here, for example, if I write a distinct, I will get only two records here, the red and black. And then in the where clause, the color in red and white. So this is how we can work with the subqueries in different conditions. Another flavor of subquery, let me write this one. So here you can see we have implemented different group by aggregate function having clause, and if I execute, I'm getting this result set. So here we have to use one more, select asterisk from and close this one. So if I execute now, so here you can see we are getting one syntax error. What we have to do here, we need to use alias as like you can use any name, aggregate data. So now if I execute, so here you can see I'm getting the color, total price, and all these things. So we can also fetch like individual column, color, and total price. See, this total price is pop up here, and then we are only interested in max price. See, max price, as these columns were not the part of production.product table. So previously we are fetching the select some columns from the production.product table, and now this is the virtual query, like this is a subquery that contain the data or it behaves like a data source for this select statement. And when you execute, it works perfectly fine. So what is the benefit here? We implement all the logic complexity in the inner side, and here it's very plain and simple query. Here only we have um, fetch some of the columns that were needed, and there is no complexity here. So we have discussed some of the subqueries flavors. So we can close this video here, and we will continue the remaining part in the upcoming videos. If you like this video, please subscribe our channel, and if you have any question, please write in the comment section. Thank you.